In this video, we're going to start with the new chapter, the periodic table. We will look at how it is arranged, and we are going to look at some trends in the periodic table later. Let's start by looking at the relationship between the position of elements and electronic structure. The periodic table was designed by Dmitry Mendeleev, who arranged the elements in order of increasing atomic mass and atomic number. Remember, atomic mass is the number of protons together with the neutrons in the nucleus, and atomic number is the number of protons. Mendeleev left gaps for missing elements that were not discovered at the time he designed the periodic table. So during the past few years, those gaps were filled as scientists continued to discover new elements. Groups and periods. The elements in the periodic table are arranged in 18 vertical groups and 7 horizontal periods. So what you see as you move vertically on your periodic table, vertically from the top to the bottom, those are your groups, and we have 18 of them. And then as you moved from left to right on your periodic table, you have your periods, and we have 7 of those. Let's look at the groups. The groups are numbered from 1 to 18, and we distinguish between the main group elements, groups 1 to group 8, or 1 to 2, and 13 to 18. And then we have the transition elements, groups 3 to 12. So the transition elements are found in the middle. Usually when we refer to group 1, when we refer to group 3, we're actually referring to group 13. And when we refer to group 8, we usually refer to group 18. Because in grade 10, we usually do not work with transition elements. So you're going to have to get used to that. The groups comprise elements with similar chemical and physical properties and electron configurations. A few groups have special names. How do we name the groups? Group 1 elements, we call them alkali metals. Group 2 elements, we call them alkali earth metals. Group 7 or 17 elements, we call them halogens, and group 8 or 18, we call them the noble or inert gases. The periods. Periods are numbered from 1 to 7. The first period has 2 elements, the hydrogen and helium. Periods 2 and 3 have 8 elements, and then period 4, 5 have 18 elements. Within a period from left to right, there's a systemic change in the properties of the elements. We will see this as we do trends in the periodic table. The properties of an element, as well as its position in a particular group or period, are results of the electron structure of the atoms of the element. Again, we're going to see this as we look at the trends of the periodic table. The electron configuration and the periodic table. Remember, we did electron configuration, and we even did 2 types of electron configuration. We did the spectroscopic electron configuration and the shorthand electron configuration. So when you start from hydrogen in the periodic table, going to the right to helium, each element has 1 more proton and therefore 1 more electron than the previous one. For example, hydrogen has 1 proton and therefore 1 electron. So helium, because helium is in front of hydrogen in the period, in the first period, helium will have 1 more proton and 1 more electron than hydrogen. So helium will have 2 electrons and 2 protons because hydrogen only has 1. From the figure on the previous page, we can conclude that each atom of a specific element has an inner electron structure that has been filled in the preceding period, and that inner electron structure is the same as the structure of the preceding noble gas. So remember when we did the shorthand electron configuration, we did say this. We did say that we replace the inner electron structure of an element with the structure of the preceding noble gas. The number of valence electrons of an element is equal to the group number. We also did valence electrons. All elements in the same group have the same valence electron structure. So for example, take oxygen and sulfur. Both oxygen and sulfur are in group 16, or you can say group 6. So their valence electrons, they both have 2 valence electrons. All elements in the same group have the same valence electron structure. Okay, we've already said that. The outermost energy level of an element is the same as the period number. Okay, so this is an example of aluminium. Aluminium is found in group 13. So aluminium actually has 3 number of valence electrons in the outermost energy level. So aluminium, its shorthand electron configuration will be the structure of neon. So neon in square brackets and then 3s2, 3p1. Why is that? Because the inner electron structure has been replaced with the preceding noble gas. And for aluminium, since aluminium is in period 3, the preceding noble gas for all period 3 elements is neon, and the preceding noble gas for all group 2 elements, period 2 elements, period 2 elements is helium. So because aluminium is in period 3, the preceding noble gas is neon. Hence, we have replaced the inner electron structure with neon. And then looking at aluminium, it is in group 13 or group 3. So it has 3 valence electrons. So in its outermost energy level, it should have 3 electrons. So for 3s, we have 2 electrons because we know that the s orbital can only carry 2 electrons, can only carry a maximum of 2 electrons, and 3p will carry the other electrons since there are 3 valence electrons. We can divide the periodic table into 4 blocks, the S, P, D, or F blocks. The name tells us the type of sublevel or orbital in which the outermost electrons occur. For example, your groups 1 and 2 are the S block elements, groups 13 to 18 are your P block elements, groups 3 to 12 are the D block elements, those are the transition elements, and the lanthanide and actinide series are the F block elements. So for grade 10, we are not going to do transition elements or the lanthanide and actinide series. We're just going to do the S block and P block elements. Then we have atoms that have half-filled outer energy levels. Those are stable and they react by either losing electrons and removing a half-filled level, or they accept electrons and fill up the half-filled level, or they share electron pairs between their nuclei. So those that lose electrons, they find it better for them to lose electrons. Those are your group 1, 2, and 3 elements. Why do they find it better to lose electrons than to gain electrons? It is because it is much more easier for them. Take sodium, for example. Sodium is in group 1. Sodium finds it much more easier to lose the 1 electron in the s orbital than to gain all 7 electrons to fill the outermost energy level. So it prefers to lose the 1 electron. And then those that prefer to accept electrons, those that react by accepting electrons, they prefer to accept electrons because it is much more easy for them to accept electrons. Take oxygen, for example. Oxygen just needs only 2 electrons to fill its outermost energy level. So it prefers to gain those 2 electrons than to lose all the 6 electrons that it already has. And then there are those like carbon that prefer to share electron between their nuclei. We're going to see how carbon does that when we do chemical bonding, covalent bonding to the specific. And then we have atoms with a completely filled outer energy level, and they are very stable and most do not react. Those are your group 18 elements, your inert or noble gases. your neon, your helium, your argon, they mostly do not react because they already have filled outer energy level. Because remember we said that most elements, when they react, they want to be either losing or gaining electrons. But your noble gases or inert gases, they do not need to be gaining or losing electrons because already they have a completely filled outer energy level. Let's look at valency of the main groups. What is valency? Valency is the number of electrons an atom has to lose, gain, or share in order to obtain a stable noble gas structure. So this is a table showing the group number, valency electrons, and the valency for all the main group elements. When I'm talking about main group elements, I'm talking about groups 1, 2, and then 13 to 18. But remember, I said that for groups 13 to 18, we're going to be using 3, 4, 5, 6, 7, and 8. So the valency electrons for group 1 elements is 1. The valency electrons for group 2 elements is 2. The valency electrons for group 3 elements is 3. Valency electrons for group 4 elements is 4. Valency electrons for group 5 elements is 5. Valency electrons for group 6 elements is 6. And valency electrons for group 7 elements is 7. Valency electrons for group 8 is 8. Okay. And then the valency, which is the number of electrons that they have to lose or gain or share, we obtain that by saying group number minus 8 for groups 5 elements to group 8 elements. And then for group 1 to 4 is just the group number. The valency is equal to the group number. So the group 4 elements, they are the ones that prefer to share their electrons. But we're going to see that as we do chemical bonding in the next chapter. That is it for this video. On the next video, we are going to be doing periodic repetition of properties of elements.